Hello, I welcome you all in this presentation related with the subject materials processing fundamentals and practical. In this particular presentation, I will be talking about one of the bulk metal forming process which is called extrusion. Extrusion process is primarily used for making the long cylindrical jobs of uniform cross section. This process is similar to what we observe in case of pressing the toothpaste and the way by which toothpaste comes out in form of a one particular shape or particular cross section. So, where the material is filled in the tube, when we pressurize the tube through the opening, material comes out in a particular shape and that continues to do so until we keep on pressurizing or material within the tube is exhausted. So, our extrusion process by and large is similar to that of the pressurizing the tube to take out the toothpaste from the toothpaste tube. Okay. So, the process is primarily used for making the long uniform section bars, tubes and other materials which are further processed for making the engineering components. Okay. Extrusion can also be used for making the other types of the products, like the raw material in form of food can also be extruded to make the similar shape, the products of the food. Then the polymers can also be extruded to make the tubes, pipes and films. Concrete is also extruded to make the bars. So, depending upon the material, the approach is same, but the material can change, and accordingly the conditions we need to use for the extrusion, those also be changing. Okay. So, in this presentation basically these are the topics: the approach of the extrusion and the types of extrusion. Like, we can apply the impact force. Certain cup shaped products are made through the extrusion by applying the impact, okay, or pressure can be applied, or we can apply pressure to ensure that the material is extruded through a particular opening of the die, or we can also use the friction to heat the materials. So, for the different purposes, the pressure force can be applied in different ways. It can be impact, it can be pressure, or it can be friction also to heat the material and to realize the extrusion of the polymers. So, this is particularly used for polymers. Polymers pressure is used for the metals, and this is also used for the metallic sheets. Hydrostatic extrusion is particularly used for making the extruded component of the metals having the limited ductility. Okay. So, the fluid is used to build up the pressure and facilitate the extrusion. Depending upon the temperature conditions, the extrusion can be hot or cold. Mostly metals are subjected to the hot extrusion, while other soft metals, polymers etc., can be subjected to the cold extrusion. Depending upon the direction of flow of the material during the extrusion, it can be direct or indirect. So, these are the different ways by which, or the factors on the basis of which we can group or categorize or classify the extrusion process. Then, how about the metal and extrusion? In this one, basically we want to talk about the flow behavior and the factors affecting the flow of the material during the extrusion. So, like extrusion speed, the temperature, yield strength, ductility, crystal structure etc. In the mechanics of the extrusion, we will try to talk about that how the force varies during the extrusion, how much force is required, how to determine the stress and strain associated with the extrusion, and at the end we will also be talking about the common defects which are observed in extruded components. Okay. So, we will see that in extrusion is a basically bulk metal forming, where significant deformation of the material takes place to get the desired shape of the material in form of bars, rods, tubes, pipes etc. So, the bulk deformation is one. Mostly metals are subjected to the hot extrusion, but if the metal is of the low yield strength, high ductility, or the material to be processed is offers the reasonably good the flow behavior, then it can also be done under the cold conditions. So, this extrusion is used to produce long uniform cross section bars, rods, tubes etc. These can be square, circular or any other shape which is desired for a given purpose. Okay. The stock material which are extruded are like say metals. Aluminum is one of the most commonly used extruded material. The polymers in form of plastics, food items and concrete. These are the various kinds of the materials which can be processed through the extrusion with or without external heating. So, accordingly we will have the hot or cold extrusion. In polymers, sometimes the friction is used to heat the material and to realize the desired flow behavior and the ability of the material which is to be extruded. So, with or without heating, and the stock material with or without heating is forced to pass through a nozzle of the die having the shape as per the requirement of the cross section to be produced. Okay. And extrusion facilitates having very large reduction. You see, significant change or reduction in cross section can be realized, and this is quantified in terms of the extrusion ratio. So, this can be like 30 to 50 times less than what it was in the beginning. Okay. So, the reduction in cross section area is quantified in terms of the extrusion ratio. Say initial cross section is A1 and final cross section is A2, cross sectional area is A2. This extrusion ratio, this can range in from 30 to 50. So, this is a huge reduction in cross section which is possible through the extrusion in one go, okay, or in one pass. So, if we try to see simplest case, say this is our die, okay, we can say extrusion chamber, and here we have the die with the given opening. This opening can be circular or it can be rectangular, it can be of any other shape as per the requirement. Okay. This is the raw material which is in hot condition. This is the plunger which will be pushing the raw material, and through the suitable mechanism the plunger will be pushed by suitable ram. This plunger is pushed, plunger will be pushing the raw material, and when the raw material is pushed or subjected to the very high pressure, then the material starts flowing to come out of the nozzle of a particular shape, and accordingly we get the extruded part. So, this reduction in cross section here initially very large diameter and finally we get the very smaller diameter. So, this reduction in cross section is huge, and that is quantified in terms of the extrusion ratio. This is one typical example of, this is the typical approach of the extrusion process. Okay. So, extrusion and the material properties. So, there certainly material should show enough flowability, so that when pressure is applied it starts flowing out of the nozzle to realize the desired shape, and therefore, material should show enough plasticity under the extrusion condition. These may be of high temperature, these may be of the low temperature. As per yield strength of the material should show lower strength and higher ductility in terms of percentage elongation. If the material does not show these characteristics, then the resistance for the extrusion will be high. Say if the materials with the high yield strength will be difficult to extrude, because they will not be flowing and coming out of the nozzle. They will require much higher pressure, much higher temperature conditions for extrusion purpose. Similarly, if the material is showing the higher hardness, then it will require greater force for extrusion, and even it may not be possible to. So, material with the lower ductility and higher hardness, limited flowability, you see sometimes the hydrostatic extrusion is found useful. Then the surface finish that we get out of the extrusion is reasonably good, especially under the cold condition, because in hot conditions material will be experiencing the oxidation and usually compromising with the dimensional accuracy and the surface finish that is realized through the extrusion. The one good thing, when the extrusion is carried out under the low temperature conditions, material experiences the work hardening. Whenever there is a work hardening, there will be increase of field strength and a reduction in ductility, percentage elongation. So, extruded component can show increase in tensile strength and modulus of elasticity, but the ductility can be compromised under the cold conditions. Sometimes even hot extrusion also offers the reasonably good properties because of the refinement of the grain structure or particular orientation of the grains in particular direction. Okay. So, the other properties which are desired for the extrusion so that the material can be extruded easily include the viscosity. Materials must show enough the flow behavior so that when pressure is applied, it starts moving out of the nozzle to realize the desired shape. So, viscosity of the material is crucial for the extrusion under the extrusion conditions. Whenever the extrusion is carried out, extrusion creates the elongated grains in the direction of flow of the material. So, it offers the desired strength and helps in realizing the desired strength in a particular direction. And so, the grain elongation or the flow of the grain in particular direction is one aspect. The grain refinement is another aspect, where extrusion can lead to the significant grain refinement, which can improve the strength and the ductility of the material. And extruded components, especially the extrusion of extruded aluminum products, offer the good corrosion resistance. So, it is good in terms of the number of desired mechanical properties of the material which is being produced through the extrusion process. As far as the advantages in terms of the production is concerned, there is very minimum wastage, because there is very limited loss of the material in form of scales. So, extrusion minimizes the material wastage as compared to the machining from the stock material, resulting in the cost savings. So, there is no major loss of the material except the little amount of the material which will be left at the end of the extrusion. Okay. Simple to the complex, reasonably complex shape products can be made, long cylinder jobs can be made in form of bars and pipes through the extrusion with the greater ease and precision as compared to the other manufacturing process. Process is quite fast, it offers significant reduction in cross section in one go, and therefore faster production, especially in medium to the larger scale production. The shapes that are realized are reasonably close to the desired one. Surface finish is also reasonably good. So, as a result of that, the near net shape, the products which are reduces the machining requirement, and therefore extruded parts often require less machining because of the good finish as compared to that of the casting, which in turn reduces the production time and cost. So, these factors in turn improve the productivity of the manufacturing approach by the extrusion process. Extrusion is typical applications of the extrusion include like aluminum extrusion is common, and aluminum extruded parts are used in automotive, construction and electronic industry. The plastic extrusion is commonly used for making lot of items like pipes, tubes, films, etc. In textile, extrusion create the synthetic fibers, and extrusion is also used in food products and making the products of the concrete. So, depending upon the conditions which are used for the extrusion, we will try to talk a little bit about the different types of the extrusion process. So, hottest extrusion is one where the material is heated to the higher temperature, especially above the recrystallization temperature, so that it can offer the desired lower strength and greater ductility, and this is particularly good for the metals. Cold extrusion is used for the metals. When the metal is extruded at the room temperature or below the room temperature, is used for the metals and other materials like polymers, food, etc. Then friction extrusion, this is a process where charge is moved with respect to the extrusion die to produce the, to homogenize the structure, to realize the desired flow by the frictional heating and make the products desired. Impact extrusion, it is a high speed process where punch impacts a slug of the material, forcing it to pass through the die to produce the cup shaped products. Okay. Hydrostatic extrusion is particularly used for extruding the low ductility and high yield strength metals, wherein the material is pushed through the die with the help of high pressure fluids. So, we will say this is the die, and here we have the closed chamber. So, material is placed here, okay, and all around this we have the fluid. So, fluid is pressurized. So, the pressurized fluid will be pushing the raw material to pass through the die. So, this is what is done in case of the hydrostatic extrusion. Further, according to the direction of the movement of material during the extrusion, we have direct extrusion or indirect extrusion. Okay. So, but before that, let us talk about a little bit of the extrusion ratio. I have defined this. Extrusion ratio is defined as a ratio of initial cross sectional area to the final cross sectional area of the material which has been extruded. So, initial cross sectional area is obtained from, say, this diameter d, and the final diameter of the extruded part is small d. So, pi by 4 d square divided by pi by 4 is small d square. This ratio will give us the extrusion ratio. Okay. Further, depending upon the direction of the material during the direction of flow of material during the extrusion with respect to application of the force applied for the extrusion, we categorize the extrusion as a direct extrusion or indirect extrusion. So, say the direction of the application of force is this on the plunger, okay, and the plunger will further be pushing the material against the die and the extrusion chamber. So, when material is pushed to such an extent that to such a critical limit, the material starts flowing out of the nozzle and gives the desired shape to the raw material which is being pushed. So, when the pressure is applied, force is applied through the ram and the material after extrusion starts flowing in the direction of the force being applied, then we call it as a direct extrusion. So, here the force is applied in say in this direction and the material starts extruding in the same direction, it starts moving during the extrusion in the same direction. So, that is the direct extrusion, and in case of indirect extrusion, say this is the plunger through which the force is being applied on to this is the ram through which force is being applied on the plunger or this dummy block, and which will be further pushing the raw material. But in this case, during the extrusion, material flows in direction opposite to that of the force in which it is being applied. Okay. So, here the force application direction is this and material flow direction after the extrusion is just opposite to that of the force application. So, here the material starts flowing through the plunger itself. Okay. So, the plunger is hollow. Okay. You can see the plunger is hollow and the material from the die is mounted in the plunger itself. When the force is applied with the help of plunger, the material starts flowing through the die through the hollow plunger and the extrusion happens. Okay. So, in this case, this is called indirect extrusion. So, extrusion process can classify it as a direct or indirect extrusion depending upon the direction of movement of the extruded material with respect to the application of the compressive force being applied for the extrusion purpose. So, indirect extrusion involves the movement of the material while coming out of the nozzle in direction of the applied compressive force, while it is opposite in case of the indirect extrusion. The type of extrusion, whether it is direct or indirect, that affects the force required for the extrusion. Direct extrusion requires higher force for facilitating the extrusion as compared to that of the indirect extrusion. Okay. And the reason behind this is the friction between the raw material and the die wall interface. Okay. So, in case of the direct extrusion, the friction will be acting at all these interfaces between the raw material and the die wall chamber, and the friction force must be overcome for ensuring the movement of the material. Okay. So, the friction force coupled with the force required for extrusion, both these will be needed in case of the direct extrusion. But in case of the indirect extrusion, the material, when the force is applied through the dummy block with the help of this plunger, the material directly starts extrusion starts in the material directly. So, the force required, the indirect extrusion involves only the force required for extrusion only, there is no frictional effect. Okay. And therefore, the force required for direct extrusion is much higher than the indirect extrusion, because the friction component at the extrusion chamber and the raw material interface is absent in case of the indirect extrusion. Here material directly starts extruding in case of the indirect extrusion. Okay. So, the type of extrusion affects the force required to manufacture a product by this process, primarily due to the difference in friction encountered between the stock material and the wall of the friction chamber. And this variation we can easily see in case of the indirect extrusion, force required during the extrusion process as a function of the ram movement, maximum force required in case of indirect extrusion is limited, while in case of direct extrusion this force is very high, and this difference is attributed to the frictional difference that will be present due to the friction between the raw material and the extrusion chamber interface. Okay. So, indirect extrusion experiences the higher friction force due to the relative movement between the stock material and the wall of the extrusion chamber before taking the shape after passing through the nozzle. So, this is one aspect, and therefore, between the extrusion chamber, say this is the die, and here we have the raw material which is being pushed, okay, with the help of the plunger. Okay. So, here to reduce the friction between the extrusion chamber and the raw material, what we do, we put the lubricating materials here. Okay. This lubricating material must be able to sustain the extrusion conditions. Okay. So, these materials may be in form of molten glass, graphite, grease, oil, etc., in such a way that it can withstand the extrusion temperature conditions. Okay. So, to reduce the raw material or stock wall interface friction, suitable lubricants like combination of the molten glass, graphite, grease, oil, etc., can be used with can withstand, so that the interfacial friction can be minimized and the maximum force that is required to start the extrusion can be minimized. In indirect extrusion avoids the possibility of the interwall stock material friction due to the inherent nature of the process itself, wherein material flows through the nozzle in direction of the opposite to that of the applied compressive force. So, this friction is absent, therefore, it requires the lesser maximum compressive load, compressive force which is to be applied to start the extrusion. Okay. Material must have enough flowability, and it should show the plastic behavior to facilitate the extrusion. The material must flow should show enough flowability during the extrusion to facilitate the production of the desired size and shape. The flowability of the material during the extrusion depends on the type of material, which basically we see in terms of the yield strength or the ductility or the thermal softening. Okay. So, the different materials will be showing the different yield strength. Say aluminum is very low yield strength, it softens very rapidly, very high ductility. So, extrusion will be easier as compared to the steels which will be requiring much higher ram force for the extrusion because of high strength, relatively low ductility and higher resistance to the thermal softening. So, the material is certainly one of the big factor that will be affecting the flowability, okay, because of the difference in the strength, ductility and thermal softening behavior. The temperature which is being used for the extrusion is the another factor, and extrusion speed is the another factor. So, these three factors will be determining the flow behavior of the material under the extrusion conditions. Okay. All these aspects determine the ease of extrusion, extrusion force desired, mechanical and metallurgical properties of the extrusion. Okay. Because if the temperature is low, material will show great work hardening tendency, and at a higher speed it will tend to become more brittle, of higher strength and lower ductility, especially under the low temperature conditions. That is why extrusion speed is also important. So, temperature, metal and the extrusion speed, these are the three important factors that will be governing the end properties of the extruded product as well as the ease of extrusion and the extrusion force which is desired. Okay. So, under the mechanics of extrusion, we will try to talk about the force required for extrusion, stress and the strain related to the extrusion, and the power needed for extrusion, and how the force required for extrusion varies with the type of extrusion. Okay. So, the force for extrusion depends on the plastic behavior of the material under the extrusion conditions, that is the temperature and extrusion speed. And in case of the direct extrusion, it is the friction at the metal extrusion chamber interface contact. Okay. Metal extrusion chamber interfacial friction is absent during the indirect extrusion, and therefore, it will require lesser force for the extrusion. The friction force must be overcome before commencement of any extrusion in case of the direct extrusion. Okay. So, as we know that the extrusion reduction in cross section due to the extrusion is measured in terms of the extrusion ratio, and which is quantified as a ratio of the initial cross sectional area to the final cross sectional area, and this can range from 30 to 50, which is very high value. This is known as extrusion ratio. So, where A1 is the initial cross sectional area and A2 is the final cross sectional area of the component after the extrusion. This extrusion ratio is used to calculate the true strain of the material experienced by the material during the extrusion or due to the extrusion. Okay. So, while neglecting the influence of the friction and redundant work, true strain in extrusion can be obtained from the log of the REX, that is the extrusion ratio. So, log of A1 divided by A2, that is how we get the true strain in case of the extrusion. Okay. Compressive stress or the pressure that is required for the extrusion to be applied using the ram for extrusion under the ideal conditions of no friction, no redundant work can be obtained simply from the average of the stress required to facilitate the extrusion, okay, and the strain REX. So, average stress and the strain that will be experienced by the material during the extrusion. So, the pressure required for the extrusion will be obtained from this. Okay. So, pressure or the compressive stress that will be needed, sigma average multiplied by log of RE. Okay. So, wherein sigma average is the average flow stress due to the deformation of the material, and that we get from the, say, x is the constant and the true strain raised to the power n divided by 1 plus n. Okay. And n will be absent in case of the hot extrusion because the work hardening exponent is absent, and in that case the stress will be x raised strain raised to the power n only when we are dealing with the hot extrusion. Okay. So, this is one way of determining the average stress, okay, desired for the extrusion. So many empirical equations have been developed to determine the stress required and the true stress and true strain that will be experienced by the material during the extrusion. Okay. So, the one of the empirical relation which is used to obtain the true strain and the corresponding ram pressure during the extrusion is this, where instantaneous the true strain is obtained from this relation A plus B log of REX. So, A is constant 0.8 and B will be ranging from 1.2 to 1.5 depending upon the extrusion die angle. These constants A and B increase with the increase of the die angle and ram pressure to perform the indirect extrusion. The ram pressure to perform the indirect extrusion can be based on the Johnson's extrusion strain formula, which is this PEX into the average strain and the true strain, where this is average stress is calculated based on the ideal strain rather than the extrusion strain. Okay, effect of the friction in direct extrusion is accounted using the following expressions to quantify the pressure required to overcome the interfacial friction. So, what we do, additional pressure needed to overcome the interfacial friction into the area which is being considered in case of the extrusion. So, this will be giving us the frictional force, means this will be equal to the friction force and the area of contact, that will be further equal to the normal load being applied, friction coefficient and the interfacial friction contact area. So, when these are equated, we get the PF, that is the pressure needed, additional pressure needed on account of the friction, okay, pi d1 square by 4, that is the initial cross sectional area, and PF is the additional pressure needed, and mu is the friction force, and the PC multiplied by pi d1L. Okay. PF is the extra pressure needed to deal with the billet or the raw material container interfacial friction. Pi d1 square by 4 is the initial cross sectional area, mu is the friction, interfacial friction, Pc is the pressure exerted by the billet on the container wall during the extrusion, and the pi dl is the area of the interface between the billet and the container wall. So, when these are equated, we get the additional extra pressure, for facilitating, for starting, for overcoming the friction. When we are considering the direct extrusion, it will have the two components. One is the strain that is to be induced to facilitate the extrusion, and another the friction to and the force required to overcome the friction. So, the pressure to be applied on the ram for direct extrusion PEX, that will be including sigma y, the strain, and the 2L by d1. So, this is the one typical equation which can be used to determine the pressure in case of the direct extrusion, and this second component will be absent in case of the indirect extrusion. In that case, we will have sigma y strain Sigma y is basically the taking care of that the average stress aspect. So, and this is sigma y into the strain. Okay. So, the force required for the direct extrusion is obtained from the force required for the direct or indirect extrusion is obtained from the extrusion pressure Pex and the initial cross sectional area of the billet, that is A1. So, the force will be like Pex into the area where F is the force to be applied on the ram for extrusion, and the power for required for extrusion can be obtained from the force required for extrusion and the extrusion speed. So, P is the power and Fex is the force to be applied on the ram, and V is the ram speed. So, this will be giving us the power required for the extrusion. So, if we see the difference in this component will be leading to the difference in the direct force required or pressure required for direct extrusion as compared to the indirect extrusion. Okay. So, now we will talk about the extrusion defects. No? If the extrusion conditions are not proper, say the material properties are not favorable under the extrusion conditions, extrusion speed is not optimum, die design is not optimum, then these will be leading to the variety of the issues related to the products which are being made. Okay. So, the melt fracture is one which occurs due to the flow instability and caused by stick and slip phenomena during the extrusion, especially in polymer. So, this will be leading to the features on the surface like this. A rough surface is obtained due to the improper temperature control during the extrusion, and the center cracks like extruded surface will be having the cracks at the center, that is also called center burst. It is an internal defect and that occurs due to the unequal flow or very high under the very high extrusion ratio conditions. Piping defect or the back end defect is commonly observed in aluminum extrusion, especially at the end of the extrusion, which is caused by the factors like insufficient butt end material or improper die design. Uneven deformation is the another kind of the defect which is observed in extruded products, like, and this is caused by the improper extrusion, improper temperature or improper die design. Scratches occurs due to the high friction between the die and the extruded material which is being extruded, or the high friction the extruded product and the die interface or the rough die surface itself. Poor dimensional control happens and the dimensional accuracy occurs. Poor dimensional accuracy or the very high tolerance is observed when the extrusion speed is high, temperature is not controlled properly, or the die design. Contaminations of the material which is being extruded can occur due to the impurities in the material, or the die can lead to the defects. Degradation in the material properties can occur due to the excessively high temperature being used for the extrusion purpose. Moisture and trapped air can also lead to the defects, and compositional and chemical heterogeneity related issues cause the defects in the extruded materials. This is particularly true for the polymers where or the composite materials where variety of the ingredients are added, heterogeneity is not good. So, the compositional and heterogeneity issues will be causing the defects in the extruded products. Now, I will summarize this presentation. In this presentation, basically I have talked about the approach of the extrusion, what are the various types of extrusion, mechanics related with the extrusion, and what are the common defects which are observed in the extruded products. Thank you for your attention.